steps of getting the two statements. Drop the absolute value marker for the first one. Switch the inequality and the number for the second. All right, general observation. If I have absolute value of something is less than a number, notice what you get. You get two numbers and everything in between. Two numbers, everything in between. That's for less than. If you get greater than a number, it's two numbers and everything to the outside. Two numbers, everything to the outside. So we can generalize and say that absolute value is less than a number. Give me something like this. Absolute value is greater than a number. Give me something like this. Okay, and this guy's called, this is another instance of the word interval. This guy's called interval. Which means that this guy must be called an, this is an interval, this must be an, I'm sorry, what? Outerval, that's exactly. Don't look this up in dictionary guide. But you will find it on your test. So it's nice to be in class and hear the local names for some of these presentations. Hey, isn't that descriptive? Interval, everything in between 2 points. Outerval, everything out from 2 points. Hence the name. Hasn't made the Webster's yet, but I'm hoping it will. If I indoctrinate enough of you, you will go to the four corners of the world with the idea of the outerval in your mind, until it becomes a common part of universal conversation. Or not. All right, let's work some problems. Oh my gosh, right away we have an application. Absolute value is less than 3. Look at your notes. Is that going to be an interval or an outerval? An interval. Absolute value is less than an interval. And by the way, between what and what? Can you tell? 3 and negative 3. It's going to be between 3 and negative 3. And you could go ahead and solve it and get that idea, but that one's pretty obvious. It's going to be in between 3 and negative 3. So I got to find the graph that represents that. How about number, this one? That one? This looks pretty good. This one? That one? No. Any? No. That one? Yeah. This one? You like this one? You guys are picking. All right. That wasn't too bad, right? Interval between 3 and negative 3. All right, number 4. Determine whether each value of x is a solution to the inequality. Now you got 2 ways to do this. Number 1 is the long and arduous way. I can literally take each of those numbers, substitute in for x, and see if it gives me a true statement. Or I could solve the inequality, draw a little picture of the thing, and see what fits into my math here. So 4x plus 9
-5.
What you going to do first?
Put the 9 on both sides.
Subtract the 9. Absolutely. And?
Divide the 4.
Do I need to switch the inequality?
No.
No, I'm dividing by a positive number. Negative 14 over 4. We might want to put that into more usable terms if we're going to draw number line. 7 over 2. 3.5. Okay. So 7 over 2 is what it simplifies to. 3.5 gives me a better visual picture. Here we go. So it's everything to the left of negative 3.5. And that's another reason why you want your x's first in your inequality statement, is because the direction of the arrow is also the direction of your graph. I got a picture of it. Is negative 5/4 in that graph? No. Especially when you realize that negative 5/4 is negative 1.25. Nah, it's not there. In fact, it's right there. How about negative 17/4?
Yeah.
That's the same as negative
4.25.
4.25. That's further in here. Yep, it's right there. Okay, so it's good. How about 0?
No.
How about 1?
No.
We got our answer. Right. Hey, I got double inequality. What you gonna do first? Add 8. Add 8. Now you get x by itself. Let's get rid of that 8. And about 2. We're good. And here's some more fractions that you hoped for. We can call that 2.5. Less than or equal to, that's a 4.5. Between 2.5 and 4.5, got a parentheses here and a bracket there, right? Mm-hmm. So that's the picture of the set that's good. Now let's check out these values. Negative 1/2, is that good?
No.
Negative anything's not good, right? Negative 1/2 is not good. Is 7 good?
No.
No, it's between 2.5 and 4.5. Is 9/4 good? You got to figure out what that is.
No.
9/4 is
2.25.
2.25, so it's right there, just outside. How about 9/2?
Yes.
That's the same as 4.5. Is 4.5 in the set?
Yes.
What says it is?
Bracket.
Bracket says it is. The equal to sign. So that's good. Now, ladies and gentlemen, prepare to be amazed. Is everybody ready? You have your desk seatbelts fastened. We missed the problem. No, actually we didn't. They missed the problem. Stinking Webason missed the problem, all right? So if you want to get this one right, you're going to have to violate your conscience and click 9/4. It's a wrong web assignment screwed up, all right? This is just another example in your collegiate life, ladies and gentlemen, when you have to put down to get credit something that you know is wrong. That will happen more than once, believe me.
It cost me about 30 minutes last night.
Did it really?
Reworking that problem.
It's right now. Okay. According to web assignment standards, that's what you got to put down. But you and I both know that the only right answer is 9/2, right? So we'll just play along with web assignment and pretend like 9/4 is the correct answer. I can throw you for a loop if you're working the problems and you're double checking and you're trying to figure out what you did wrong. All right. Solve the inequality in sketch. Ooh, sketch. Solving the inequality is not such a big deal. Just add 3, right? So I get x is less than or equal to 11. So what they're going to actually use this problem for is helping us to sketch a graph. In this case, x is less than or equal to 11. So let's see. What do I do? Anybody know what I do here? Do I do a bracket at 11?
No, the
Oh, the other bracket. Yeah. So, and I lift it. Okay. Now, how do I
You click on the pencil.
pencil? Do I have to just drag it or just?
I think you just click on it. Just click on the line.
Ah, cool. What do I do? Oh. I think of 2 things at once. It's overwhelming. So drag the ending symbol and pencil the double check there. Good job, you do that?
yeah.
Solve the inequality sketch. What are you going to do first here?
Multiply it by 8.
Multiply by 8 and then take it from there.
Well, can you go back to that one? Will you multiply by 8? You multiply by 1 by 8?
Yes, sir. Every single term. The 1, the fraction, the x, that's 8x, 32, everything's about 8. Every single term. Solve the inequality in sketch. You want to do this one? Right, let's do this one. It's got a new look to it. It's the latest in inequality fashion.
The best one I had to do, like I'm already done with this section. See, I got done with this section this morning. So I came to class.
All right, imagine you're presented with this expression on a test. What you going to do first?
Change.
Distribute the negative sign.
Okay. Apply the negative, distribute the negative, however you want to phrase it. Okay, no more parentheses. Now what you going to do?
Add 5 to every portion.
Okay, get rid of the -5, so that's a +5 everywhere. Then you're done. Drop a -4. Hey, can I do that in double equality? Sure.